Hi, Tim Spann here. I want to introduce you to my talk here, Building Real-Time Pipelines with FLaNK. And the case study today is transit data. I have been doing real-time and IoT and big data and ML and edge stuff for a while. You could find my content at Medium and at GitHub and at datainmotion.dev. Contact me on Twitter or LinkedIn. I run some meetups and have worked at a couple different places. If you're looking for information on streaming stuff, definitely reach out. I do a weekly newsletter that covers all this technology, plus stuff for open lakehouses, LLM, Gen AI, edge stuff, open source, databases, big data, small data, fast data, weird data, structured, unstructured, all that stuff. If you like to get a weekly subscription, I do that in LinkedIn as well as Substack. If you don't like subscriptions, I put this all in GitHub so you can scroll whenever you want and see what you want to look at. I run some meetups in New York City. Just did one, New Jersey, Philly, and virtual. Join one of the groups, and I cross-post them all. You're able to join live in person, join live via YouTube, or watch later recorded on YouTube. And we cover a lot of things. I have myself, I often do a talk, but we get talks from, I had someone from Data Squirrel. I had Victor from Star Tree talking about Pinot. We talk about FLaNK, big data, fast data, Gen AI, lots of different fun stuff. So definitely join and get some good topics there. Now, speaking of good topics, there are lots of ways to get real-time data and lots of sources. Now, if you're trying to learn how to work with them, often these are deeply embedded into corporate data centers or corporate clouds, and you just can't get them. Well, unfortunately, there is a source of data you can get. Transportation data is generally available to the public. Now, you may need to sign up, you may not. I've documented where that is, and there's a lot of links in here to show you how to get your own local one, depending on where you live. Now, the Metropolitan Transportation Authority, the MTA, is the one for New York City, which is the largest in the U.S. So they have a decent amount of data getting pushed through the system. It's a pretty cool way to get data. And we use Apache NiFi to grab this from REST endpoints, get them into Kafka topics after it's enriched and transformed, and then we make it available to SQL so we can run real-time queries, real-time analytics on this, maybe push this to a downstream Kafka topic or to Iceberg or Kudu or some other data store, or make available via a materialized view that is a REST endpoint with JSON, which can be read by things like a Jupyter Notebook, front-end applications. A lot of things can read REST endpoints, fortunately. Now, around the world, lots of different transit systems. I did a talk at Community Over Code, formerly known as ApacheCon, last year in Halifax, Canada. Really cool place. Well, they had a transit system, and it happened to follow the GTFS real-time spec, which is very commonly used. It is the spec that lets Google Maps load where these different transit systems are in real time. There's a couple of different feeds generally available. Vehicle positions, this could be bus or something else. Where is it? Updates on the trips going around. Did something change? Did something get delayed, stopped? And alerts, is a bus broken down? Is a road closed? Is there construction? Things you might want to know about. So we get all these different feeds as frequently as they're published. This could go down to the seconds. Depends how quickly you need it, how much horsepower you have to manage thousands of records coming constantly. We get it in NiFi. NiFi sends out some messages to Slack after enrichment, routing, transformation. We put some data in Postgres, because along with these real-time feed, there's a more static feed that gives you things like, what's the name of the bus? What's the name of the routes? All the routes. All kinds of lookup data that's pretty static, doesn't change too much. They usually provide this in a big zip file. You unzip it, pull out all the usually comma separated values, and load that to your tables. I can do that automatically with NiFi. We could also send out alerts to Discord and Slack where we need to. Push this data in a clean format into Kafka topics that FLaNK can query with standard SQL. And it can produce downstream cleaned up or aggregated Kafka topics, push this into Iceberg or Kudu or other data stores like Postgres or MySQL or whatever else you might have there, just as 3 buckets. And then finally, push out a materialized view. This is JSON formatted data at a REST endpoint, and this can be made available to a Jupyter notebook, front-end dashboards, mobile apps, whatever makes sense for you. And again, pushing it to Iceberg so we have an open source lakehouse to store our data at any scale, regardless of where we want to store that. Again, that could be public cloud, private cloud. Cloudera makes that pretty easy. Now, I was in Brazil last year, and they have a transit system as well. It's called the SP Trans. It is documented REST endpoint, but it's all in Portuguese. So that made it a little difficult. It didn't follow the GTFS spec, but I was able to get it pretty easily and do the same sort of things. And again, I've got articles and videos documenting that as another example. And then I'm like, New York, Halifax, Sao Paulo, all over the world, they all have public APIs. I wish someone would aggregate these and put them somewhere. Well, someone did for almost every transit system, at least the ones doing GTFS. Mobility Data has this on their GitHub, and they provide a file that has them all. Yeah, so one download to rule all the transit systems. So I download that, parse it, and then again, most of them are the GTFS real-time for positions, updates, and alerts. Now, some of them require a login, some of them don't. Right now, I just do the ones without a login. Put the ones that need a login on the side because most of them require a multi-step process. I may be able to automate that with NiFi and LLM. I don't think they want you to do that. You probably should manually register for all these and make sure they make sense that you need to see them. So I've done that for a couple, and it makes sense, You probably don't want every transit system in the world, especially some of the larger ones, all happening at once. And again, same idea, send it wherever it needs to go, but also send some of that textual data, maybe to something like Milvus or Pinecone or Chroma or Solar, so you have that in a vectorized format for helping out with maybe making LLM calls, or I could send that right to an LLM to do summarization, to do question and answers on lots of stuff, because remember, some of this is textual data, so I could use that in a textual format. And again, I thought everything's solved, everyone's using those formats. Well, close to home, I looked at the Philadelphia SEPTA system, and they've got a bunch of different APIs, none of them covered by that other one. So I documented that, got articles on that. So there's another one. And it's not just this short alerts telling you bus 7 is going to this location at this speed with this many people on it. There's also public street cameras out there telling you, look, there's traffic. Well, showing you in another format, so we can go multimodal, grab these videos and still images. I show you how to do that. And then we can run some analytics on them. Again, combine them with the other data so we could start getting closer to be able to making really smart decisions on how people can travel around. And again, combining this with your own data. So this might be just for, I'm trying to get people into my office or trying to get people to a meetup. Well, which way should they go? Is there factors out there that's going to make it, slower or more difficult? Rain is another thing I grab from weather. I can look at street cams, see that there's a lot of traffic. All those things together, telling people, hey, we're going to postpone the meetup. We can't go because there's too much traffic. The subway's down. Trains are delayed. It's just a mess out there. Let's do it virtual, do it next week. That sort of thing. Now, you heard me mention the MTA in New York City. Well, some of their data isn't in that format. Thank you. There's a registered subway feed to get, and it's a little different. So I wrote an article on that one, how to get that. So we can get around New York. Like for me, I can get to Philly, New York, New Jersey, all that data. I've got another one for New Jersey Transit, which is another format. They have some GTFS, but they've got some others. So we get that in another way because, of course, I've written some articles on these. When you get the slides, you can go into all these. They're also linked elsewhere. Now, important part of that technology underneath this transit use case is FLaNK. That's part of the FLaNK pattern, FLaNK AI, whatever I want to call it. FLaNK, NiFi, Kafka in the middle iceberg. SSB is Cloudera's version that lets us query data from these endpoints in SQL. Just call them the standard FLaNK SQL. But also let us build these materialized views. And again, I mentioned that before. These are really helpful to have because I can access it pretty easy from a Jupyter notebook with pandas. So, as a data scientist or analyst, you don't have to know Kafka. You don't have to know how I got you that data, whether it came from GTFS real time. Maybe I grabbed some from the static table. Maybe I injected in some data from the weather and other sources. It doesn't really affect you. You get it in a nice, clean JSON format at a REST endpoint and just read it in with your pandas. You don't have to worry about this aggregate SQL that I might be doing, which is nice in FLaNK. You support things like maxes and sums and groups. All those things you expect to be able to do in regular SQL. Being able to make this available to everyone. If you don't want to go right to those endpoints, you could just write SQL. Now, if you use the right tools out there, Cloudera will auto-generate a table for you, so you don't have to manually set these up and figure out what your fields are and your primary keys, and you have timestamps and all that. This is just going to grab it from the correct topic and read it as each event comes in. So this is not static SQL. This is not a one-time look. You get what's there now, depending on do you want the current or the earliest. And then every time an event comes in, you get it. So it's just going to keep popping down in your query. And you deploy that, it runs. And it could push it downstream into downstream things pretty easily. Again, the tool can help build these tables from Kafka topics for you real easy. So you don't have to manually do it. The next piece in the puzzle, really important. This is our, I don't know if he's the captain of the team here. He makes sure we get data going wherever it needs to go. If you don't know how to get data, look at NiFi. The new 2.0 version includes the ability to run Python components at scale, and I'm using that to do really cool Python libraries to do GTFS parsing, to do LLM stuff, Hugging Face libraries, ton of great Python stuff out of there. We are on the latest version of JDK 21 that's out there. That adds a lot of performance. We scale up and scale out really easily with NiFi. So if you need to handle every transit system in the world, not a problem. I've got some friends out there running 100 nodes, pulling in hundreds of millions of records a second, not a problem. Got a rules engine built in there. Lots of cool new stuff in NiFi 2. NiFi is a nice tool because it lets us handle all those formats. Remember I said a zipped file of CSVs? Well, I guess you could do that in Python or manually download it. Well, NiFi can grab that zip, automatically pull out all those files in there, validate them, and then grab that data, push it right to Kafka as a CSV, or convert it into JSON or Avro or whatever format you like there. Pretty easy to do. And we can handle images, so I can talk to those cameras. I could grab your documents, important now for large language models, because I want to grab that HTML markdown, grab out that text, parse it, chunk it up, get that into all the different vector stores, regardless of which one it is. I can do that with sound and videos as well. Send that to any of the clouds. Do whatever we need to do with social and chat data. And also interact with any of the database cloud services out there, whether that's Cloudera ML, anything from Amazon, Hugging Face, Watson, all those different vector stores. Real easy. And to make this even better, inside of NiFi is a lineage of your data. It's called provenance. It says everything that happened to your data, so you'll know how much you got, when, all the metadata, without changing the data itself. This can also be used in third-party apps. You could push it to a database, push it to Kafka, or just have NiFi parse this data and see, did I get the data I expected? I subscribed to a data feed. They're supposed to give me 50,000 records a minute. I got 12,000. Something's wrong. I can prove that. This is solid lineage of your data, audit data, whatever you want to call it. Great for debugging as well. I use this NiFi to be able to run Google Gemma real time against LLMs. Linked here in the QR code. Again, for these data pipelines, get that external context ingested wherever it needs to go. Build prompts for things, because I could prompt against transit data to say, where's my bus? Figure it out. Get any context I might need for RAG architecture. Round trip to whoever we need to send data. Whoever can subscribe to REST or Kafka, I can call Discord. I could host a web endpoint, act as a website, act as a REST endpoint, call any REST endpoint, call hundreds of different sources of data, FTP, SFTP, HTTP, name any of those, we got it. Now, another thing that's a new feature within something like FLaNK SQL, I can call Cloudera machine learning models over REST. So while things are running, get those results real time, be able to call any kind of models, including LLMs. And if you're not running Cloudera machine learning, I use NiFi to act as a proxy to different downstream machine learning and Gen AI sites. So NiFi will act as a REST endpoint, parse what you really want, validate it, enrich it, and make a call into, in this case, Hugging Face, which is hosting a Google Gemini model. So I can pass through a question, get back the results as part of a SQL. I'll show you that. Really cool. This is an example of the SQL. I call a function, which is a small JavaScript Java wrapper that's calling my REST endpoint. And I pass in the text that I have stored coming out of this Kafka topic, which happens to be all the Slack messages I receive, because NiFi can act as a Slack bot. It grabs everything that happens in your Slack channel. I push it into Kafka, and now I could use real-time SQL to call my LLM. Pretty easy, but it's documented here. You want to see that in depth. Got a lot of different resources and articles. Again, you'll get these slides. I'm going to go into the demos. I know I don't have a ton of time, so I want to make sure I got through all this stuff. All these slides are available to you. Hopefully we haven't timed out here, me talking so much. Just making sure I can log in here. Okay, we're good. So this is Apache NiFi. This is an example flow to grab all the transit speed data from the New York Transit system. And I pull it in from a REST endpoint, which has a thing to let you grab 1,000 at a time. I add a timestamp and a unique ID to it, parse out the lat long, and then I start using it for my applications. What's nice with NiFi is between every step in a program is a configurable queue. And this queue you could set if you want load balancing. I'm running in one node on my laptop, but I can run on 100 nodes in the cloud, or 1,000 nodes on premise, 10,000 nodes in Google, wherever it makes sense for you. But with this, I can start and stop things either manually here in the UI or through REST endpoint or command line. And this is a buffer, so I'm not going to lose my data. I have this stop, so when I want to run a demo, I could do that. And since NiFi is so fast, and if I show you this in a demo, 1,000 records went in a second, pretty boring. I'm going to manually slow down how fast I send data to the system. I'm sending only 5 records a second, so it's not too fast. Like, even that's a little fast. I might need to grab some more data. And I'm sending this to a Kafka topic. I'm also doing the same for MTA data, because I'm going to show you joining a couple of sets of data through Kafka topics. Again, slowing this one down. Otherwise, we sample it in the viewing, in the output, so you'd only see one record. It's kind of sad. Okay, and then third, I'm going to join this to another feed. This is a Transcom feed. This is a multi-state agency that gets data on traffic conditions. So I'm going to join the traffic data with the MTA data for speed and the New York City traffic data from something else, and to one query. As you see, we're getting, it's still too much data. It's still scrolling super fast, hard to see it because you're getting all of this very quickly. And it's things like, okay, crane operations on a certain street, track replacement on a subway, a lot going on there. If you look at the SQL here, again, this is the sample. I can go into the actual application here in FLaNK, and you could see I'm joining all these tables together, and then joining a second one, getting all these records and connecting them together. Now, this data can be made available as an insert to another Kafka topic, or into Kudu, or into HBase, or into a file system, or into JDBC. Or for here, I'm pushing that out into materialized view. But I'm taking all the fields I want from a bunch of these 3 different tables. These are Kafka topics. And I'm doing full outer joins on all these. And there's also a SQL hint here that says, go back to the earliest Kafka data you have. So I'm looking at all the data I have plus all the events that are currently coming in. And we join them on approximate lat long. It's kind of crazy, but I can join these 3 different sources of data based on their lat longs. Now, there's calculations you can do, and I have a function to do, Havershine distance and some other distances, and I play around with those. Like here, see, we're looking at the distance between these lat longs. There's a lot of things you can play with to join based on where things are. And I'm getting a bunch of this data. Let's get more data. It's mad at me for looking at this much data without doing anything with it. And you can see the lat longs. And the reason we do this is so we could push it out to something like this, like a dashboard. Now, this is OpenStreetMaps. And using that output from this query, I can push that and read that from a map. And you can see I can put a lot of maps out there. This is the Halifax one. And I'm also pushing it to a table. Got one for, this is the MTA one. And you can see where things are really busy. Yeah, it's usually busy down by Union Square. Lots of trains and stuff's over there. So we got that. And you could sort it by different things, lat long, whatever. And for all transit systems, you can see this one's a little different because data's popping up everywhere. Now, if I loaded them all, you're going to see the US, Canada, Europe, Asia, tons of stuff is going to have data. But what's cool with the OpenStreetMaps, I could just pick one of these locations and zoom in and literally get, an individual point. This one's in Michigan, just to give you an idea. So these are just running. Ooh, I'm finally running out of data here. I'm going to stop these controls and leave them for the next demo. We also have other sources of data here. This is, remember I mentioned that Transcom. This is how we get it. There's an RSS feed. Again, there's so many different sources of this transit data. So here I convert it from XML to JSON. As you see, I don't know what those fields are. Doesn't matter. NiFi figures it out. It's pretty cool. In another use case, here I'm grabbing some of that Philadelphia bus data. It's coming through as JSON. It's a little weird JSON. So I clean it up, add a couple of fields in here based on some of the metadata I had, and then I can make it send it over to Kafka. You can see here I sent a record. I could go over to Kafka and take a look at all these different fields. We can see which one's really building up. There's that New York transit speed data. And I can see it's coming in as JSON. I can look at that SEPTA data. That's probably bus alerts is the most recent one. And we take a look at the bus alerts. Okay, unknown cause. Thanks, but there's a delay there. You know, you get the idea. Tons of different ones we're doing. There's that MTA and the trans data. So those are the three ones we're joining together. But I'm pushing Slack messages to a group. You know, we can look at all the different Slack messages I put in there. You know, and that's just my Slack group. If you want to join it, I've got links elsewhere. Tells you how to join this, and you could do things like ask questions. You can upload images. I've got NiFi things to build reports from that, so it'll take a look at an image, see what's in it, using part of that. Also put labels in there. That is a happy cat. I don't think it's a sad cat. I don't know why they did it. He is not wearing pajamas. I don't know what you're doing. There's a picture of me on stage. It may be doing the analytics for, but just to give you an idea for that. So we've got a lot of different things we could look at once. Again, Slack messages, real-time transit, whether it's from Sao Paulo, Brazil. Let's see what topic they're putting it in. Make sure we're going to the, we can look at that one. Send a bunch of data to that one. And we look in here and we could see who's getting a bunch of data back. It's probably Brazil. Though I might have spelled it, let's see, which Brazil did I put it? Or did I put this all in transit? That's the problem when you got a ton of different data sources. Yeah, this one. I was thinking put every transit data in the world into one topic, one table, but some have extra fields. And then I've got massive amounts of data. I mean, just running this for a little bit, I've got 100,000 records. It makes things tough on your laptop when you're running, you know, all these different systems plus a database, plus a browser, all that fun stuff. But gives you an idea, different things you could do with the system in, you know, one programming environment, hosted on my laptop. I'm running lots of different things here. This is that all transit. I download one CSV file, parse it, grab only the real-time ones. We can grab the other ones. If it's got authentication, let's parse it. Otherwise, we'll save that for later. Take a look at ones that need, you know, a login somewhere. If there's one interesting to people, let me know. Ooh, Quebec. You know, probably the next city I go to, I got to go to Seattle. So if Seattle's in one of these. And then I update a Postgres table here to list all my transit systems, and this saves it to the database with inserts. As you see, it's all different data going into a table. I don't know what the fields are. It doesn't matter. NiFi figures that out for me, which is nice because I don't know what it's doing. And then what happens is when I want to actually run it, I can read all of the systems in there when they change. NiFi has the ability to tell you that there's data changes. So this will have the state of where we are. What was the last one it looked at? Or if I want to just have it on a schedule, I'll just read that from the transit system every 2 minutes and look at every single transit system. And as you can see here, I've got some records built up because I've been running this for a while. And I have a Python component that takes this data and converts it from GTFS to JSON. So we can run one of those. And comes in. If the data is a little weird, you know, it's supposed to be a standard spec, but sometimes the data comes in broken or missing or empty. So I'm trying to figure out if there's a way I can make that useful. Still putting that on the side for now. As you can see, most of the records are not junk. So, you know, there's 150,000 backed up here. Just because I paused it. Because, I mean, how many of these you want to do? And this is going into a Slack channel. This is going into my other Slack group that I just used for debugging. Otherwise, people are going to get all these transit messages and pictures of highway cameras with augmentation on it. I don't know, you want to subscribe to that channel. This is a great way to debug, especially if I'm not sure, like, where am I running in the world? What transit system? Am I in the cloud? Where am I? Easy to debug. Thanks for joining me. We are out of time. Hope you like my session. Thank you.